Good day everyone, this is Sir Gil Bansuelo Jr. Welcome to another Math Kwentuhan with Sir G. Another great lesson to be discussed. Without further ado, join me. In today's lesson guys, we're going to deal with permutations. And when we talk about permutations, take note guys, order matters. So let's define permutations. Permutations deals with an arrangement of items in a particular order. For instance, in a particular competition, we always have the first place who won the gold medal, the second place who will won the silver, and the third for the bronze. And for the election, our previous presidential election in the United States of America, where President Biden won the presidency versus President Trump. So order matters in permutation. So let's define it. Permutations of n objects taken R at a time is the number of permutations of R objects taken from a group of n distinct objects is denoted by the following symbols. When I say distinct, I mean noticeably different. So again, when we talk about permutations, we deal with arrangement where order matters. So let's deal with these symbols and take a look on the permutation formula. Again, using these notations, permutation is always equal to n factorial all over a quantity of n minus r factorial. So, kahit alin yung gamitin natin dito guys, no? P quantity nr, npr, then p nr. These are a representation of the formula for permutation. So, any of these will be equivalent to this n factorial all over a quantity of n minus r factorial, which is the formula for permutation. Ito yung gagamitin natin in solving permutation problems. Where n factorial or n would be the number of distinct objects and r are the objects to be taken at a certain time. So let's try to have some sample problems. So let's find the number of permutations in the following given. By the way, we read this as the permutation of 4 taken 2, permutation of 6 taken 3, permutation of 7 taken 4, permutation of 8 taken 3, and permutation of 5 taken 2. So let's apply the formula. Take note that what is written on the left side are your n, and what is written on the right side are your r. And please take note as well that r cannot be greater than n. It might be equal, but it can't be greater than n. Then let's write the formula. So the formula tells us that n factorial divided by a quantity of n minus r factorial is equal to the permutation. So in this case, our n is 4. So changing all n by 4, and all r and r by 2. Then simplifying, expanding 4 factorial, that is equivalent to 4 times 3 times 2 factorial divided by 4 minus 2 factorial is equal to 2 factorial. So in that note, we're going to eliminate 2 factorial and another 2 factorial on the denominator via cancellation. Then, what is left is 4 times 3, which is equivalent to 12. I hope that is clear. For number 2, let's do the same. Again, our n is 6. That's why we arrive at 6 factorial divided by n minus r, which is 6 minus 3 factorial. Then expanding 6 factorial into 6 times 5 times 4 times 3 factorial. We end up to 3 factorial because the denominator dictate us to do so, because 6 minus 3 is equal to 3 factorial, wherein we can cancel both 3 factorial on numerator and denominator, which leaves us 6 times 5 times 4, which is equivalent to 120. Let's proceed on number 3. What is the permutation of 7 taken 4? Again, our n is 7. That's why we arrive at 7 factorial. And n minus r, which is 7 minus 4 factorial. Then expanding again, 7 factorial times 6 times 5 times 4 times 3 factorial. Because 7 minus 4 is equivalent to 3 factorial. Again, just the same on the first two exercise. We're going to cancel both 3 factorial on both numerator and denominator. And what is left now is 7 times 6 times 5 times 4, which is equal to 840. Let's proceed on the next exercise. Number 4. What is the permutation of 8 taken 3? Alright, again, n is 8 factorial divided by 8 minus r factorial. Then again, expanding 8 factorial into 8 times 7 times 6 times 5 factorial. We will stop at 5 factorial because 8 minus 3 is equal to 5 factorial in the denominator, which we can cancel out. Then what is left now is 8 times 7 times 6, which is equivalent to 336. And finally, the permutation of 5 taken 2 is equivalent to 5 factorial divided by a quantity of 5 minus 2 factorial is equal to, expand 5 factorial into 5 times 4 times 3 factorial divided by 3 factorial is equal to, will leaves us, after canceling 3 factorial on both numerator and denominator, will leaves us 5 times 4, and that is equal to 20. And this is the basic problems and skills to be understood in permutation. So I hope nakuha natin, guys, no? Again, if there are some confusions and you feel you need to recall, please feel free to pause the video, rewind, then rewatch as many as you wanted to, as many as you needed to. Then please practice using your pen and paper. And in that way, we can ensure that you will acquire the skill. Okay, so let's proceed on our next exercise. In the Olympics, 10 teams are competing in the final round of bobsledding competition. By the way, bobsledding competition is the sport of sliding down an ice-covered natural or artificial incline on a 4-runner sled called a bobsled, bobsleigh, or a bob that carries either 2 or 4 persons. In this question, in how many ways can 3 of the bobsledding teams finish first, second, and third to win the gold, silver, and bronze? If you could notice, guys, order matters here because we discussed the first, the second, and the third. The first cannot be the third, and the second can't be the third as well, because the first is the first, and the second is second, and the third is the third, to win the gold, silver, and bronze. So therefore, this particular problem is under permutation. So, bobsledding looks like this. Ayan, so it could be 2 or 4 members. Ayan, then they will slide in up to the finish line. Ayan. Alright, so let's find all the given here. So our n here is 10 because we have 10 teams. Ayan. That is our n. And our r is 3 because we are asked to find the different ways can 3 bobsledding team can finish first, second, and third to win the gold, silver, and bronze. So, that particular case will serve as our R, and the number of teams or the number of distinct objects in this particular problem is the 10 teams. So that's why n is equal to 10. So using our formula, P of permutation of 10 taken 3, so that is equal to n factorial, which is 10 factorial, divided by n minus r factorial, which is 10 minus 3 factorial, which is equal to 10 times 9 times 8 times 7 factorial. We stop at 7 factorial because 10 minus 3 is equal to 7 factorial, which will be cancelled to 7 factorial on the numerator as well. Then what is left now is 10 times 9 times 8. So therefore, there are 720 ways to finish this team to get the first, second, and third to win the gold, silver, and bronze. So there are 720 ways. So I hope it is clear. So let's proceed on our next problem. Permutations with the repetitions. So let's find the number of distinguishable permutations of the letters in the word Philippines. Take note that Philippines has 11 letters. We have 3 P's, 3 I's, and one of each H, L, and ES. And to solve this kind of problem, we're going to count the number of letters in the entire word. And we're going to put that in the numerator, then we put factorial way. So 11 factorial way to rearrange these 11 letters. And if you could notice, we have 3 P's and 3 I's. In that case, there are 3 factorial ways to arrange these 3 P's and these 3 I's. So we're going to put it on our denominator just like this one. So we will arrive at 11 factorial, the total number of letters in the word Philippines, and 3 P's and 3 I's. Then let's simplify. Let's expand 11 factorial. So we arrive at 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. So we cancel 2 3 factorials on both numerator and denominator. And what is left is the expanded form of 3 factorial, the other 3 factorial on the left, which is equivalent to 3 times 2 times 1, which is equivalent to 6. That's why we're going to cancel as well 6 and the entire 3, 2, and 1 on the denominator. Now, if you could notice, what is left in the denominator is 1. So, wala na siya. So, we're now going to multiply 11 times 10 times 9 times 8 times 7 times 5 and times 4. And that is equal to 1,108,800 number of distinguishable permutations in the word Philippines. So I hope it is clear. Again, if there are some confusion, you may always pause the video, rewind, rewatch, and try to solve it again using your pen and paper. So let's continue. In how many ways can 8 persons be seated if 2 of them wanted to be next with each other? So siguro mag-best friend to. Gusto nila magkatabi sila palagi. So let's illustrate. So we have 8 persons to be seated in a row. Pero these 2 persons wanted to be sitting next with each other. So on that note, 7 and 8, for instance, will be counted as 1. So, therefore, we will arrive on this. Instead of 8, we count 7. Because we're going to count 7 and 8 as 1. So, that is equal to 7 factorial times 2 factorial. Sir, question, saan ang galing yung 2 factorial? Very good question. It came from these 2 person who wanted to be seated with each other. But because there are 2 factorial ways to arrange 2 persons. So that's why we multiply 7 factorial times 2 factorial. And that is equal to 10,080 ways. So there are 10,080 ways to be seated, these 8 person, when 2 of them sit next with each other or wanted to sit. Ayan, no? So, gusto nila magkatabi sila palagi. Ayan, no? So, yan. So, mag-best friend. Alright. So, pwede rin pala yung permutation sa ganito, no, guys? So, again, please take note. Pag gusto nila magkatabi, we have to count them as 1. And we have to consider as well the number of ways na ma-rearrange natin yung kung ilan man yung gustong magkatabi. In this case, we have 2. That's why we have 2 factorial ways. Alright. And multiply. Okay? Next problem. And let's proceed on circular permutation. So, circular permutation is the total number in which n distinct objects can be arranged around a fixed circle. So, for instance, ito ay table, no? Then, we have 6 chairs here. So, for case number 1, clockwise and anti-clockwise or counterclockwise orders are different. Ayan. So, for case number 1, where orders are different, so our formula is P sub n, where n is the number of distinct objects, is equal to n minus 1 factorial. So, supposing, ito yung person to be seated here. So, if you could notice, meron siya makikitang 3 seats in front, 1 to the left, and 1 to the right. Bakit ba kasi ang question ay, bakit ang formula natin nag-minus tayo ng 1, no? Yun yung question natin. So, dito natin makikita, guys. So, again, nung umupo yung tao on the first seat, so kahit saan siya, pwede siyang umupo dyan, di ba? Halimbawa, sa isang occasion, so umupo siya dito kunyari. And it has 6 seats in this circular table. So, what he can see in front is 3 empty seats in front, 1 to the left, and 1 to the right. And that is also true if he sits on the next seat. No? So, again, he's facing 3 seats in front, 1 to the left, and 1 to the right. So, therefore, kung ano yung nangyari natin dito sa first seat, yun din mismo yung nangyari sa second seat. So, let's try sa pangatlo. Kung makikita ninyo, pag upo niya sa third seat, meron pa rin 3 upuan sa harap, 1 on its left, and 1 on its right. So, pareho lang. And so on. So, anong ibig sabihin nito? Anong ibig sabihin nun, guys? So, ibig sabihin, there is only one way to take the first seat. One way lang. Alright? So, yan. So, para mas maintindihan natin, let's recall how 8 persons be seated in a row of chairs. So, I just forgot to put 8 chairs here, no? In a row of 8 chairs. So, to illustrate, supposing these blanks represents 8 chairs in a row. The question is, in how many ways can 8 persons be seated in the first seat in this row? Of course, 8. So, pag nakaupo na yung isa, how many persons can be seated on the second chair? Of course, 7. And, if you could notice, kung umupo ako dito sa first seat, wala akong makikitang vacant seat dito sa kaliwa, pero I've seen 7 seats on the right. And that is different when I took the second seat because I will see 1 seat on the left and 6 to the right. This is, so that is the difference between the circular and the row arrangement of chairs. Because in circular, Kahit saan tayo mo po guys, pareho lang yung makikita natin. 3 in front, 1 on the left, and 1 on the right. If it is 6 chairs, di ba? So, kahit saan tayo pumunta, pare-pareho lang, no? So, ibig sabihin, there is only one way to take the first seat. Pero dito, in a row, it has 8 particular person to be seated. So, pwedeng 8 person yung umupo dito sa unahan. Walang magbabawal sa 8 person. So, lahat sila entitled. Pero dun sa circular, isa lang yung pwedeng umupo dun sa una, then mag-adjust na yung mga susunod. Diba? Kasi nga, iisang view lang yung nakita natin, no? So, let's continue solving this. So, after doing so, in this particular problem, this is equivalent to 8 factorial ways, or there are 40,320 ways. These 8 persons be seated in a row of 8 chairs. Ayan. So, let's continue discussing the circular permutation, no? Ayan. So, marami. Ayan, there are 8 ways to fill the first seat. But in the circular, ayan, so in a circular table, each seat in a circular position can be filled only once. Ayan. Or, kasi nga, di ba guys, na-explain ko sa inyo kanina, no? If I take this seat, I can see 3 chairs in front, 1 on its left and 1 on its right. Pag lumipat pa rin to dito sa kabila, halimbawa siya yung unang person, if he took the second chair, ganun pa rin yung makikita niya. 3 on its front, 1 on the left and 1 on its right. Diba? Pareho lang. So, ibig sabihin, there is only one way to be seated on the first seat in a circular permutation. So, if you could notice, from 6, we will arrive at, so the second, for instance, I took this chair, no? So, the next chair, whether it could be in the left side or on the right side, 5 persons na lang yung pwedeng umupo dyan, no? Then, followed by 4, 3, 2, and 1. Or pwede rin dito sa kabila, 5, 4, 3, 2, and 1. And, we know that 5, 4, 3, 2, 1 is equivalent to 5 factorial. Then, 1 times 5 factorial is equal to 5 factorial or equals to 120 ways. So, ano yung realization natin dito, guys? If there are n distinct objects in a circular permutation in a table, we need just to subtract n by 1. No? So, that is n minus 1 factorial. So, I have 6 chairs here, minus 1, I will arrive at 5 factorial. So, yun yun. Yun yung dahilan bakit tayo nagmaminus ng 1 sa ating permutation on circular function. Or circular permutation rather, in case number 1. So, let's take another example. Suppose you are sitting 8 people at a circular table. In how many ways can you arrange them around the table? Supposing I took this chair. So, what I can see in front is 5 chairs, 1 to the left and 1 to the right. If I took the second chair, ganun pa rin. Meron pa rin akong 5 chairs in front, 1 on its left and 1 on its right. So, it is true, no? So, on that note, simplihan lang natin. Gamitin natin yung formula. Sabi natin, to get the permutation or circular permutation in a table, circular or a round table, we just need to identify our n or distinct object. In this case, we have 8. Then, subtract by 1. Then, put a factorial. So, therefore, P sub n is equal to a quantity of n minus 1 factorial. And n objects here, we have 8 person to be seated. Then, 8 minus 1 is equal to 7 factorial. Or there are 5,040 ways to sit in a circular table. So, that's how to deal with it. Okay? So, very easy lang, guys. So, we just need to identify the number of distinct objects, subtract by 1, and factorial. So, let's discuss naman this next problem. For case number 2, clockwise and anti-clockwise orders are the same. So, the same. So, kasi, if we are going to label this key as A, B, C, D, E, and I flip the keyring to its left, di ang mangyayari, yung B natin, ito na, B, C, D, E. So, pareho lang sila. Ibig sabihin, they are symmetrical. So, if on that note, hindi natin bibilangin yun. Kaya kailangan nating mag-divide ng 2 sa n-1 factorial. Kasi nga, symmetrical sila. Pag pinunta ko sa left, yung keys, at pinunta ko siya sa right, pareho rin yung mangyayari, no? So, kaya kailangan nating mag-divide ng 2. So, ito ay nangyayari lang kapag gumagamit tayo ng ring, bracelets, etc. Pero sa circular table, hindi natin kailangan mag-divide ng 2 kasi hindi naman natin pwedeng baliktarin yung tables, di ba? So, it can be applicable to rings only. Ayan. So, why we divide 2 to n-1 factorial na keyring? Supposing each keys will be labeled as follow, just like what I said. A, B, C, D, E. If we move the ring on its opposite location, clockwise or counterclockwise, it will be symmetrical or the same to B, C, D, A. If you could notice, guys, no? Nalipat lang yung A dito sa kabilang side. Pero yan pa rin yun. So, kaya kailangan natin mag-divide para hindi na natin yun mabilang uli. Kasi nga, they are symmetrical or the same. Again, nagdi-divide lang tayo ng 2 in a key, ring, or bracelets. So, for example, a key ring has 5 keys. In how many ways can they be arranged? So, I have 5 minus 1 divided by 2. Then, we will arrive at 4 times 3. Then, times 2 factorial divided by 2 factorial. Then, there are 12 ways. So, divided by 2 and 2 factorial are the same because 2 factorial is equivalent to 2 times 1. Okay? So, don't be confused, no? If I put here 2 factorial, not divided by 2, because they are just the same. Okay? So, 2 factorial is equivalent to 2 as well. Alright. Then, I guess, it's your time to solve the following problem. So, let's permute. Let's see if you acquired the lesson I've talked about today. So, please take a screenshot on the following problem. Okay. And here are the other problems. So, I will give you 30 minutes to finish these exercises. Pause the video before playing it again for you to be able to solve the key corrections, no? So, please pause the video for 30 minutes. And your 30 minutes is gone. So, let's see if your answers are correct. So, for numbers 1 to 5, so the permutation of 7 taken 2 is equal to 42. The permutation of 6 taken 3 is 120. The permutation of 8 taken 6 is 20,160. And the permutation of 9 taken 6 is 60,480. And for number 5, the permutation of 8 taken 4 is 1,680. And for number 6, 7, 8, 9, and 10, for number 6, we have 1,716 possible selections. For number 7, there are 362,880 ways. For number 8, we have 2,520 ways. For number 9, we have 34,650 ways. And for number 10, we have 17,280 ways. So I hope you got all of these correct. But if not, don't be sad. You can always pause this video, rewind, try to rewatch, do it again. Okay? Until you master the skill. Alright? So, until next time, until our next math kwentuhan, again, this is your math guru, Sir Hill, saying keep safe and ingat tayo palagi.